Well, this is the exact same thing that we did yesterday, okay? And frankly, it kind of is, except for one big thing. We have this word right here, the converse, okay? And when we talked about those statements way back in chapter 2, at the beginning of chapter 2, we talked about a conditional statement. And so our conditional statement was what we did yesterday. And we said, if we have parallel lines, then all of these things would be true, right? All of these pairs of angles are either congruent or supplementary or whatever it might be, okay? But now as I look at these pictures here, if I look at lines J and K, do we know if J and K are parallel? No. Do they look like they may be parallel? Yeah. But do we have the arrow on to show that they're parallel, okay? So I can't, and I tried to talk to you guys yesterday about how important that is to recognize. Well, today, what's going to happen is those lines will not necessarily be parallel to start with. So what we're going to do is we're going to flip it today, and we're going to say, let's prove that J and K are parallel, rather than them telling us that J and K are parallel. So yesterday, they would tell us these two lines are parallel, and then I would prove something about the angles. Today, they're going to give us some information about the angles, and we're going to try to prove that these two angles, or these two lines are parallel. Okay, so in this case, if angle 2 is congruent to angle 6, do we know if these two angles are congruent? How would I know if angles are congruent?
That there's parallels.
Okay, if the lines are parallel, but right now they're not, okay? But if I just gave you a picture, or two pictures, and I said, are these angles congruent or not? They have to have the same marking, or they have to have the same angle measure, right? Do we know the angle measure of 2 and 6? No, but do they have the same marking? Yeah. Right, and that's the one thing we've said about geometry over and over again, is that the markings mean everything, right? This marking here means this angle and this angle are congruent. So angle 2 and angle 6 are congruent, okay? So if the angle 2 and angle 6 are congruent, what kind of angles are they? The corresponding, right? And so really what this statement is saying is, if corresponding angles are congruent, then we have parallel lines, okay? So I'm just kind of shortening that down into a real quick statement. If corresponding angles are congruent, then we have parallel lines. So therefore, because those two angles are congruent, we can now say J is parallel to K. Okay, and all of these are going to be very similar, okay? Angle 4 is congruent to angle 5. So what this statement is going to look like, if alternate interior angles are congruent, then we have parallel lines. All of these are going to be the converse of what we did yesterday. Yesterday, they told us that we had parallel lines. Today, we are proving that we have parallel lines. So the whole statement has been flipped. And the fact that we know these two angles are the same because they have the same marking, then once again, we would say that J is parallel to K. Okay? We've proven it a different way. We've proven that those two angles are congruent in a little bit different form. Okay, alternate exterior angles. Okay, once again, angle 1 and angle 8. As we look at angle 1 and angle 8, we notice they have the same marking, right? And so in this case, we're going to say angle 1 is congruent to angle 8. So we're going to say if alternate exterior angles are congruent, then we have parallel lines. Okay, so because those two angles are congruent, then J is parallel to K. So all three of those statements are very, very similar to one another. The only thing different really is the type of relationship that they have. Corresponding angles, alternate interior angles, alternate exterior angles are all congruent. If that's the case, then we will have parallel lines. Okay, the one that's different, there's 4 different relationships we've talked about the last couple of days. And we're going to continue talking about them, but the one that's different is consecutive interior angles. And what must be true about consecutive interior angles? They have to be supplementary, okay? So if angle 3 plus angle 5 equals 180, then J would be parallel to K. Okay. And as of right now, we don't really know what the angles are, okay? And we can't really put a marking in here because just knowing that those two are the same angle measure, that wouldn't be enough, right? If they were both 90, then yeah, we could do that, right? Because 90 and 90 makes 180. So if those two angles add up to be 180, then we will have parallel lines. Okay, so my statement here, just to kind of shorten it down a little bit, if consecutive interior angles are supplementary, then we have parallel lines. Okay, so I'm just kind of rewriting it in a little bit different form, kind of shortening it down a little bit. You don't necessarily have to write out this big old long statement. We just have to have something to kind of support what we're talking about. So if I had to, some people yesterday asked me, like, what do I need to say in the explanation on the big ideas? As long as I can see, like, that you're saying something that supports what's going on, that's really the most important thing. Okay, abbreviations are fine as long as we know what we're talking about when we do that. Okay, and so try to use the similar abbreviations because then we are on the same page as to what's going on. Okay, so here's the deal. Today we're flipping it up. Okay, we're still going to be solving equations. We're still going to be doing a lot of the same things that we did yesterday, but the question that they're asking is going to be just a little bit different. Rather than them saying, okay, M and N are parallel, so therefore if they're parallel, then we know these are the same. Okay, this question is saying find the value of x that makes M and N parallel. Okay, so what value of x will make these two parallel? Well, in order for these two to be parallel, what would have to be true about these two angles? They would have to be congruent, right? So 3x plus 5 must equal 65. Those two would have to be equal in order to make these two lines parallel. But I want to know what value of x is going to make that true. Okay? And that's the other thing. We got to make sure we read carefully what are they asking for. So here we're solving for x. So we're going to subtract 5. We're going to divide by 3. And we get x equals 20. It's not asking me what the measure of the angles would be or anything like that. It's just asking me what value of x. If I plug 20 in here, 3 times 20 is 60. 60 plus 5 is 65. Now these two angles are congruent, and if they're congruent, these two lines are parallel, right? Okay, so that's how you would kind of go about identifying that. Is there enough information in this picture here to determine M and N are parallel? Is there anything special about these two relationships? Do we have any relationships that are exterior?
Those are supplementary.
Okay, how come?
Because if you subtract 105 from 180, then you get 75.
Okay.
Which means that that all the ones vertical to and like matching the 75 will be 75, and all the other ones will be.
Yep, and I'm with you, okay? Now, when I make my explanation here, okay, do these two angles form any of the 4 angle relationships that we've talked about, okay? Any of the names that we've talked about? Corresponding alternate interior, alternate exterior, and consecutive interior. Those don't match any of those, okay? And those are the reasonings that we're going to use to be able to determine what's going on, okay? But here's how I could easily do this, okay? If I took 180 minus 75, that gives me that this angle is 105, right? And I can do that without knowing these lines are parallel, because these two lines, or these two angles together make 180. They make a line, right? So 180 minus 75 gives me this. These two together have to make 180. Now, what kind of angle are these two? What do we call that relationship? Alternate exterior. Okay? So here's what we're going to say. If alternate exterior angles are congruent, then M would be parallel to N. So we would say yes, this would work. But our reasoning has to use one of these four statements up here, okay? If you can use one of these four statements in some shape or form, you can prove that that's true, okay? If I can't use one of these in some shape or form, then I don't have enough information to get there, okay? And that's what you kind of have to decide. Can I use one of those theorems? The theorem that we are using is the corresponding angles converse, right? I'm rewriting it out as a statement because I think that makes more sense. That's probably what I would do because I think it makes more sense if we do it that way. If I just write corresponding angles converse, I think, do we really know what we're talking about? Plus, on a quiz or a test, you got to remember those names, right? And so I think it's easier just to write out the statement. If these corresponding angles are congruent, then the lines must be parallel, okay? But on big ideas today, I think it is going to use those names, so make sure. Okay, and that's kind of what we're doing on this next one. Angle 1 is 115. Angle 6 is 65. Okay, do those two, as of the way we have them labeled, make a special angle pair? Are they one of our four angle pairs? Okay, they're on opposite sides, but this one's outside and this one's inside, so those aren't what we're looking for, right? So what other angle could I use to prove that these would be enough? Okay, you have a couple of options. What would one option be? Yeah.
Angle 2 would be supplementary.
Okay.
And use congruent angles.
Okay, good. Angle 2 is supplementary to 115, so angle 2 would be 65 degrees, 180 minus 115. Okay, and then if this is 65, what kind of angle would 2 and 6 be? Corresponding, okay? So our statement would be something like this. If corresponding angles are congruent, then M is parallel to N. Okay? And I'll tell you this, because I think Big Ideas uses this today, you understand that they'll probably use that. Okay. I also, just to show you, there's a lot of different ways that we could have done this. These two would be supplementary. So then 3 and 6 are alternate interior angles. So I could have used the alternate interior angles converse, right? Angles 1 and 4 are vertical. So this would have been 115. And then 115 and 65 are consecutive interior angles. And they add up to be 180, okay? So there's about 3 different ways I could have done that problem. And all of them would be correct, okay? And so, as we've talked about a lot of times, is there's not always, in geometry, that's kind of one thing that's a little bit different, is there's more than one way to approach it. There's more than one way to write your answer. There's not just, this is the only way you can do it. Now, there are going to be problems where there's only one way to solve it out and only one way to do it. But there's a lot of times where we have more than one way to get to where we need to be, okay? So, if you do it one way and the friend next to you did it another way, that doesn't mean you guys are both wrong, okay? It means you both may just solved it a little bit different way. Okay, let's go to number 2 here. It's 58. Angle 8 is 132. Okay, those two are not a pair right now. Okay, so as of right now, we can't go right to a statement to prove it. Okay, so what would be another angle that I would maybe need to prove or find? 7. Okay. What would be the measure of angle 7? Okay, it would be 58. Now, can I say because this is 58, this is 58? Would that be okay? Not today, right? Because do we know these two lines are parallel right now? No. But when we do supplementary, we don't need parallel lines, right? So that's why one of the first statements probably has to use the fact that they're supplementary first. We can't prove corresponding angles because parallel lines are not true yet. Okay, so I'm going to say is 58. 180 minus 132. Now, angle 3 and angle 7 are congruent. What kind of angles are angle 3 and angle 7? What type of relationship do we call that? One's inside, one's outside, and they're on the same side. Corresponding, yep. And so we're going to say if corresponding angles are congruent, then M is parallel to N. And that would once again be the corresponding angles converse, because it's the converse of what we did yesterday. Okay, down here on these two, kind of like we did on the last page, what value of x makes M and N parallel? Okay, so here's 3 and here's 6. What kind of angles would 3 and 6 be? Alternate interior, okay? Angle 3 and angle 6 are alternate interior angles. And if those lines are parallel, those two angles must be congruent, okay? Right now, we don't know if they're congruent, but we want to force it to be congruent. We want to prove that M and N would have to be parallel. But we got to find the value of x. That makes that true. So angle 3 is 7x minus 4. Angle 6 is 3x plus 8. And we're going to solve for x. So I'm going to subtract 3x from both sides. I'm going to add 4 to the other side. And we get x equals 3. If x equals 3, then those two lines would be parallel. Okay, and what we used here is the converse of the alternate interior angle theorem. Like I said, on the big ideas today, they're going to talk about that actual name, or you could do the statement, but big ideas is going to use the name. So I just want you to get used to using the name a little bit as well, because you're going to see that on your assignment today. Okay, on the last one down here, angle 3 and angle 5, what would be true about angle 3 and angle 5? What kind of angles are they going to be? Okay, consecutive interior. Okay, and so we're going to use the converse of the consecutive interior angles theorem. Okay, what would be true about consecutive interior angles? They would have to equal 180. Okay, so we're going to write out 8x plus 3 plus 2x plus 7 equals 180. Okay, and I'll tell you this, guys, you only have two options. You're either going to set those two things equal, or you're going to add them up and set it equal to 180. Those are the only two options that you have today. They're either congruent or they're supplementary. Okay, and so don't try to do something else that we haven't been doing. Okay, congruent or supplementary are your only two options. Okay, I'm still seeing some mistakes here. Remember, these two are not on opposite sides. They are on the same side. So when they're on the same side, what are we going to do with 8x and 2x? Combine them. Yep. 8x and 2x makes 10x. We don't want to do the opposite operation unless we move it to the other side of the equal sign. We're not doing that here. 3 plus 7 makes 10. And so now I subtract 10. I divide by 10. And I get x equals 17. If x equals 17, those two angles, or two lines would be parallel. Okay? Yeah. Look at these two proofs here. This is kind of like yesterday. The good thing here is, at least on this first one, all the statements are provided. We're just kind of come up with the reasoning. Okay? First statement is always the easy statement because they are giving us angle 4 and angle 5 being congruent. So that's given. Okay? Now, just go to the statement that they're telling me here. Okay? We don't have to come up with that because it's provided to us here. On this next one, we're going to have to come up with everything. Why are angle 1 and angle 4 congruent? Vertical angles, you bet. Okay? And we don't need to know anything about parallel lines to prove vertical angles are congruent. All vertical angles are always congruent. Okay, number 3. Angle 1 is congruent to angle 5. Here's the question. Can I say that they're corresponding angles, so they must be congruent? Why can I not say that? We don't know if the lines are parallel. Okay? These two are only congruent if these two lines are parallel. We don't know right now if they're parallel. That's what we're trying to prove. Okay? If I knew these are parallel, then I could say corresponding angles are congruent, and that would be a piece of cake, right? We don't know that, right? So I can't say anything about corresponding angles because I don't know if the lines are parallel. But what could I use here to prove 1 and 5? Transitive, right? They're both congruent to 4. 1's congruent to 4, 5's congruent to 4. Because they're both congruent to 4, then they are congruent to one another. And so that is the transitive property of congruence. Okay? So then, why is G parallel to H? The converse of the corresponding angles theorem. If you wanted to write out the statement, you could say if corresponding angles are congruent, then G is parallel to H. Okay, you could say either one of these. You don't need to have both. Okay, these two mean and say the same thing. This is the name. This is what it says. So you choose which way you want to do it. Okay, if you feel like you can memorize all of the names of all these theorems, go for it. And that's probably what Big Ideas is going to do today. But on the quiz this week, I'm okay if you just say the statement. Okay, questions on that one? Everybody good there? All right, let's look at this picture. Okay, we got all kinds of lines going on here. Okay, now this one's a little bit different because look what we got. We got some parallel lines. We have some arrows on there. Now, we probably could make this into a 5-step proof, but I'm going to shorten it down. Okay. I'm going to say R is parallel to S, and that's given, and angle 1 is congruent to angle 3. So anytime there's more than one given statement, you can kind of put all that into the first statement. You could put all that into statement 1. Okay? If you wanted to, you could make it into 2 separate statements and say step 1, R is parallel to S, given. Step 2, angle 1 is congruent to angle 3, given. But I like to just combine it into one step. Okay? There's no reason to separate that into 2 steps because they're both given. Now if I do this, okay? I'm gonna go ahead and mark that on the picture. The arrows are already marked, but the angles were not, so I'm gonna go ahead and mark that. Okay, why would angle 1 and angle 2 be congruent? And what I like to do here is I like to redraw this picture. Angle 1, angle 2. I'm getting rid of line P up here, okay? I'm saying we don't really need that for angle 1 and angle 2. Why would angle 1 and angle 2 be congruent? They're corresponding angles, okay? And do we know that those two lines that form those angles are parallel? Yeah, okay? And so we would just say the corresponding angles theorem. That's the theorem from yesterday. We already know the lines are parallel, therefore corresponding angles have to be congruent. That's not the new one from today. That's not the converse. Okay, so now we have to come up with the statements here, so that's the part that's a little bit harder. How can I use the two pieces of information that we have right now to make a new statement? Angle 1's congruent to 3, angle 1's congruent to 2. So what could be a new statement that I could make here? Do we see anything that those statements have in common? Do what? Go ahead. What do you think, Adrian?
I said 2 and 3.
Yeah, they have 2 and 3, right? What are 2 and 3 both equal to? 1. Okay. So what can I say for step 3? Angle 2 is congruent to angle 3. Okay. How come? The transitive again, right? What you're going to start to notice is you're going to see a lot of these properties used over and over again. Okay. And that's the way it goes, right? I mean, sometimes we'll throw in some different proofs and some different properties, but a lot of these are set up very, very similar to one another. So now, if angle 2 and angle 3 are congruent, we're trying to prove that P and Q are parallel. What kind of angles are 2 and 3 in relationship to P and Q? Alternate interior, okay? So here's what we're going to say. P is parallel to Q. That's got to be my last step, right? That's what it's asking me to prove. It says prove P is parallel to Q, and that's what we've done. And the reasoning would be the converse of the alternate interior angle theorem. So we would say if alternate interior angles are congruent, then P is parallel to Q. Once again, you don't have to have both. This is the name, this is what it says. I'm putting them both down here so you know you have some options, okay? And I'm totally okay with either one. You just have to kind of decide which way makes more sense to you. Big Ideas, as you guys probably saw or noticed yesterday, Big Ideas is pretty specific about what they want in certain problems on especially yesterday's assignment, and today's going to be very, very similar to that. All right, let's look. This one here. The transitive property of parallel lines. We've talked about parallel lines. We've talked about the transitive property. We're kind of putting them all together into one big statement here. The transitive property of parallel lines says if P is parallel to Q, I'm going to write this out. If P is parallel to Q and Q is parallel to R, then because they're both parallel to Q, what can we say about P and R? They're parallel to each other. So really what we're saying is that all three lines are parallel, right? So we're using the transitive property, but we're using it with parallel lines. Instead of congruency, it's parallel lines. So based on that statement, if we have a picture of the American flag here, it has 13 alternating red and white stripes. Each stripe is parallel to the stripe immediate below it. Explain why the top stripe is parallel to the bottom stripe. Well, S1 is parallel to S2. Stripe 1 is parallel to stripe 2. Stripe 2 is parallel to stripe 3. Okay? And we can keep going. And I'm just going to say keep going here until we have said that stripe 12 is parallel to stripe 13. So each stripe is parallel to the stripe right below it. So if all of those stripes are parallel, what can I say about stripe 1 and stripe 13? They're parallel as well. Stripe 1 is parallel to the stripe 13. And our reasoning would be the transitive property of parallel lines. So, not the transitive property of congruency, because we're not saying anything about congruency. We're talking about parallel lines. So, still the transitive property, but transitive property with parallel lines. Okay, using that piece of information. P is parallel to Q. Q is parallel to R. So what can we say about P, Q, and R? They're all three parallel. So what I can really quickly do here is I can draw an arrow on all three of those lines. All three lines are parallel. P is parallel to Q is parallel to R. If this is 115, what's this angle right here? Okay, so be careful. The one I pointed to was this one right here. 115, right? Because those two are corresponding angles. So if that is 115, then angle 8 would be 180 minus 115. So angle 8 would be 65 degrees. Okay, I don't think we need to do that last proof because I feel like we've already done a couple like that. Tomorrow is review day.